welcome to the next installment of Amy Shows You Something from Math. This will be holes and how to find them. Holes, and I think my pen's gonna run out. There we go. All right, so holes are one of the concepts that we're going to look at in terms of our rational functions here. And while we've done asymptotes, vertical, horizontal, and slant or oblique asymptotes, as they're sometimes called, we have not talked about holes. Holes are in general a discontinuity. So they are a place within the domain of a function. So here's what that looks like. You are a function going merrily along, and at some value of x, you simply stop existing. And then you continue on, and that's the only place in the function where you don't exist. I do a bad drawing of it because it looks like it's above and below, but it's not. It's just that singular point where the x value does not exist, or the domain does not exist. Within a rational function, they are fairly easy to find. If you have an r of x that is, for example, we'll start with a factored form. Let's say we've got an x plus 5 and x minus 3. And then let's give it one more and x minus 1. And all of that is within the numerator. And then within the denominator, you've got an x minus 2. You've maybe got another x minus 5 this time. And you've got an x minus 1. So you'll notice that in the factored form, there comes a factor that can be canceled. This factor that can be canceled out indicates that your function will have a hole. It will have a hole at x equal to 1. Whatever zeroes this out is where your hole will be. So to find the point, so now we're going to find the point that the hole is skipping over. So what is the exact discontinuity? You simply take r of x, just the canceled form, so x plus 5 times x minus 3 over x minus 2, x minus 5. And you find for that placement of the hole r equals 1. So this would be at 6 times a negative 2 over a negative 1 times a negative 4, or a negative 12 over 4, which is a negative 3. So our hole is at the point 1, negative 3, whatever that might be within our graph. So that tells me exactly where that hole is going to be. It's going to be at 1, negative 3. All right? Shall we try a second example? I've got 3 of them here. Why do I? Oh no, there, I don't have that. Okay. So here's my second example. All we're going to do is find the hole. So we want to find the exact location of the hole. we've got an x squared plus 4x plus 5. So our r of x is going to be at x squared plus 4x. Is that minus 5? It's got to be a minus 5. Yeah, that's minus 5. Over, let's say, an x squared plus x minus 2. Okay? With our r of x's, the first thing we always want to do is factor them. So in factored form, this would be an x plus 5 and an x minus 1. And in the denominator, I would have an x plus 2, x minus 1. Oh, funny enough, it ended up being in the same value. Notice our x plus 1 is repeated. So this function will also have a whole. Where x equals 1. So that means that the point will be where r of 1 is if we've eliminated that. So it'll be at 1 plus 5 over 1 plus 2, or 6 over 3, which is 2. So our whole is at the point 1, 2. One more time. If we're going to find the whole, what do I got this time? Why do it's got an x squared minus 2x minus 3. All right, and then in the denominator, I think I have an x cubed minus 27. So when we factor this factors into an x minus 3, x plus 1. In the denominator, we need to recognize this as the difference of cubes. So the cube root of x cubed is x. The cube root of a negative 27 is a negative 3. And then I'm left with the square. All right. Opposite sign. Multiply the two together, 3x. Always positive that last bit. And a squared there is 9. So that'll be x plus x squared, sorry. Plus 3x plus 9. You will see, right? This time we have a common factor at minus 3. So this function will have a whole where we got x equal to 3. To find the exact point, we will do r of 3. We'll eliminate or cancel through those two, and we'll put 3 in for the remaining. 3 plus 1 over 9 plus 9, plus 9. So that's going to be 4/27. So my whole is at the point 3 and 4/27 for the y. And that's it. 3 examples of how you find the whole when dealing with a rational expression. Thank you.